Cool. Yeah, and yeah, feel free to ask any questions you have along the way. It really helps me sort of like get my thoughts together and things along those lines. But yeah, we're gonna go through and we're gonna use the Pokemon, same Pokemon app that we used for consuming APIs, and this time we're gonna go ahead and expose an API, possibly a couple endpoints if we have time. I have a hard deadline at 6, but yeah, feel free to ask any questions along the way. So what we have so far is just one endpoint being consumed, and it renders a Pokemon on our web page. And this is the call we're making that's in this service right here. So usually when we're exposing endpoints, and I know that for if you're all doing Rails engine, you're going to be exposing something from a database. So right now we don't really have a database in this app. So I think the first step is going to be to go ahead and get some tables, and or at least one table, and save the Pokemon there, and then we can expose them from there. So I'll do this similarly to how I did it in another project. I'll just create a table to store Pokemon and then save them there. And then as we call from Postman or whoever's calling our endpoints, it'll go through and call our Pokemon API and save them to the database and also expose it. So yeah, let's get started there. What should I call this branch? Endpoints. We have a Pokemon, a portal called Pokemon, so I don't want to call my table that. I'll do Pocket Monster. That's what Pokemon originally stood for. And then I'll just do the same attributes. So we have a name, a number, which I'll keep as a string. Image and shiny. Cool, there's that. Yeah, I think it looks good. So you all won't need to do this for Rails engine, since you're going to have a database to work with. You're not going to have to call it from another API. But I figured this might be more relatable since we'll actually have a database this way, hopefully. So let's give this some attributes. Cool. And then what we can do is we can sort of like dream drive it here in our facade. So first of all, we're mapping them in, or I guess we're not mapping them because it's only one Pokemon, but we can just save this as a, oh, we already used that variable. Poke. And what we can do is create a model method. And give it our Pokemon, and then we can go ahead and create that method here. And let's see if we can hit this. Cool. And we have here.
Hey, Sage, I had a quick question.
Yeah.
Is the class less than self, is that the same method as the array method when you're adding something to an array, or?
Right here?
Yeah.
On line 7. So this is basically just a way to make a block where you can put class methods inside of it. So it's the same as doing this. Like the self dot to make it a class method. So if I did that, then I would just comment out this block, if that makes sense. So it's just another way to write a class method. But if you wanted to do instance methods afterwards, you would just put them after this block. But yeah, just a syntax choice.
Thank you.
Yeah, no problem. I don't think, since I have this self there, I don't think I need to specify the class. Guess I'll find out in a second. Then we can do pokey. Is this all making sense what I'm doing right now? Just sort of saving it to the database so that we have something to work with. Okay, cool.
Are you saving it to the database or saving it to an object that is stored in the stack?
This would be to the database, since we're creating a table here. So this is, this is not a Poro, it's in our models. And this is actually going to have it's going to be in Postgres. So when we call it, it's going to, this is where we actually convert our, we get a hash back from our call, which is this hash right here. We take the 4 attributes we want when we go through our Poro, which is these attributes. And then now we're mapping in again, but this time instead of going through a Poro, we're going through an actual model. And then we're creating this class method that's saying I actually think I'm going to do a find or create by. Should do find or create by name. But yeah, we're just in theory this will work and save it to Postgres. Does that make sense for the most part, or kind of?
I think so. What are the advantages of having it saved into the database?
I guess just sort of caching, that way you have it as opposed to having to call that API repeatedly. Once the first time, calls a number 25, which is Pikachu, then the next person who calls that, you're going to get it from your database as opposed to calling externally to the Poke API.
You're doing it just to set yourself up so you have something to serve, right?
Yeah, for the most part, that's the only reason I'm doing it this way. But I'm realizing now it would have made more sense to do a find or create by, and then add the attributes once we have that, so that it doesn't create it every time in the database. But let me see if that works so far. Oops. I guess it would make more sense to actually do this on the server. And sorry if I'm making this more confusing than it needs to be. All right, so let's see if we search this one, it should go through and save it to the database as well as go through the Poro. I guess there's one way to check. Okay, yeah, there it is. So yeah, so it went through and went through the Poro, like I said, and then it went through this method and created a table. I think a more efficient way to do this would be a find or create by the name or number. And then if it already exists, then just call it. And if it doesn't exist, then create it and then add the image and the shiny, if that makes sense. But I'm going to leave it like this for now, just for time's sake, so we can get more into what the actual lesson is about, which is exposing endpoints. So let's go back to this. So this is what we're getting from our API that we're calling, and then when we want, our front end or whoever's calling our back end, we want to give them a JSON package similar to this, but we just want it to just have our 4 attributes. That's all we've saved, and that's all we care about for the purposes of our app. So let's go ahead and make a test. So what we want to do is basically like visualize a, like basically a JSON object or Ruby hash of like 4 attributes, and then just make a test based on what we want it to look like. So I think let's see if I can remember everything off the top of my head too. We'll create an API folder, a v1 folder, and then inside of here we can have a remind me, Mike, what's the naming convention for like just a view or sort of like a C or data?
I think it goes off the same endpoints like RESTful. So like if it's like if you're just showing everything from your database, it would be like an index, I think.
Index. Okay. I guess this is kind of an index. No, it's more of a show page. What do I call the other one? Let's call it show. I feel like I may be mislabeling this, but I'll let y'all know. Okay, so I'm just going to pull up another project to reference. Trying to think of the convention here.
Also, maybe I'm missing a little. What's the idea for the test right now? You're not testing like the JSON that comes out of your API, are you?
Yeah, that's it. That's what we're going to be testing is what our endpoint looks like for someone who's calling our app.
Okay.
So, yeah, because we're calling this one, so we're consuming this API really similar to like how you all do in viewing party with the movie API. But the next project is exposing your own endpoint. So what we're going to do is take this Pokemon information, save it to our database, and then we're going to expose it to our front end or whoever's calling our app.
So is this like more similar to a model test, or because like I know in our integration test we always have like a visit and then like a URL. Is that how this test is going to start? I guess I'm having a hard time wrapping my head around it.
Yeah, that's fair. It's going to be similar. So our front end's going to pass us certain queries, and then we're going to, instead of having like a visit, we're going to have like a get or like a post or
okay, that makes
delete
sense.
or whatever else. Yeah, and then we're going to basically call the endpoint like the front end would, and then we're going to test for our hash, but like really that would be like our JSON object. Yeah, I did label these a little bit differently, so I'm going to rename this one to we should be able to get our Pokemon by either name or number. So I think I'm just going to be pretty explicit. Pokemon by name or number. Okay, so we'll start off with the query param. So that's basically going to be like what whoever is like our front end or whoever's asking us for this information, what they're going to pass in. So the same way how we had an API call and we passed in a certain number to call it. So we could do, 151 for mu. They're going to give us, or we could do the name. They're going to give us that same information, and we're going to pass it forward to ours. So let's just give it as a string, and that should work. And we'll call this so this is us naming it. This is, this isn't us calling their API. This is us creating our own endpoint that someone's going to call for us. So we can name it whatever we want. We don't have to use their convention or anything. We're going to pass in params, and we're going to pass in our query params. We're going to set up our basic expectations. So the first one is usually expect our response to be successful. And then, oh. The last one of these videos I did, I saw on like the 2010 Code Help channel, like Ian watched it and like commented on it. I was like, oh, a lot of pressure to like make these little videos and then know the instructors are watching them too. So hopefully Tim and Meg do not watch it this time. And then this one I've always added to the test, but I don't know if it's absolutely necessary. And then what we can say is we can give our Pokemon a variable, and this is where we'll do the whole JSON. So we're expecting that we're going to give out a JSON response. So we're going to convert it here, our own response to the front end, into a hash so that we can test the attributes and the keys to make sure we're giving what we want. So this is where we're going to say like expect it to have a certain key and things along those lines. So expect Pokemon to first of all, we can say be a hash. And I think I can, yeah, and then we're going to say we want to have certain keys. So the keys we want to have are basically everything we're exposing. So we want to have 4 because we don't have all these attributes. We only have 4 of them. So first of all, we want our name key. And here I'll put it next to the model so we can have a reference of what we're adding here. And then we're going to, let's see, add the key here. So we want name. String, right? I think these are all going to be strings. So we can just duplicate this a few times. Cool, and I think that's, we have a pretty simple table here. So I think that's all we need to get started. But who has questions on this test?
So it's pretty much just like the inverse of testing a service for consuming an API, right? So like in that aspect, we're just testing that the structure of our return of the hash is correct. But for this, we're just testing that the structure of the JSON that we're presenting is what we expect it to be.
Yeah, yeah. Can you all still see my screen? I don't know why I lost the little green square. But yeah, that's pretty much it. Like we're just like, the front end's going to give us a request and we're going to provide the response, and we're just testing to make sure our response looks like what we want it to be. So we're going to have, a JSON object similar to this, but with only 4 lines. And I think if we use now that I think about it, if we use fast JSON, which I'm probably going to do, then it's going to be inside of a key that's data, which I'll have to add to these. But yeah, we're basically like looking at what our hash is going to look like, and then we're just saying like for each line in our hash. So if we were this company and testing ours, we would say like expect it to have key form name, expect form name to be a string, and for each line that's in this JSON response, we have 2 lines testing it. We're saying what we expect it to have the key, and then we expect that key to be this data type. Yeah,
I have
up, Andrew. Oh, sorry, it's a raised hand.
So why are we checking that it's a string rather than checking it's the specific string that we want? After all, we seem to have a specific Pokemon in mind, so we should be able to just look at what we have and say this ought to equal Mew or Shiny, and give a specific thing. So why are we giving it a more general one?
Yeah, that's a good question. I think I've seen it both ways, and I think that's totally fine. Like we could, yeah, what could we do? We could save like, we could get Mew from our database and then just save it as a variable, and then just say like expect this to be, Mew.name or whatever we call the variable. Yeah, that's totally fine too. I think it just comes down to preference at that point, since here you're testing the data type and there you're testing like what it is specifically. That's a good question. I'll try to add that too if we have time. We'll have a 3rd line for each attribute. Yeah, like I said, I'm pretty sure I'm going to have to add the key data. I think it's going to be inside of that, but yeah, I'll just do it now. So I'm pretty sure that's going to happen. All right, any other questions while I'm doing that? What is the shortcut? It's remind me, I have different key bindings. I use Java a lot in my job now, so I'm forgetting all of my VS Code key bindings. It's the, like, move your cursor down to be on multiple lines.
Shift Control.
Shift Control. Sweet, thank you. Okay, so okay, cool. So I think that's how our hash is going to look at the end. It's going to be a hash. It's going to have a key data, and then all of our attributes are going to be inside of data. Yeah, let's go ahead and run a test. And beer is my shortcut for bundle. RSpec, bundle exec RSpec. Cool. So now we can go back to our routes. Let's put our test on the right. So it should be namespace API, namespace v1, and then our actual come on. You never type when I'm sharing my screen. Did we want to call it a show or an index? What did we call it here?
What's the idea behind the V1 included in the namespace?
Yeah, good question. So with RESTful APIs, it's a lot about versioning. So if we decide we want to change the structure of this, we can make a V2. And usually with like bigger companies, they'll like give some warning to their clients and say like, this is what the endpoint's going to look like in the future, and make sure you're switching over. Then you can have API V1 and V2 on for a while while people switch over to what you're switching over to. And then eventually you can just get rid of V1, turn it off.
That makes sense. I think it was like that in the movies database that we just consumed. It was on 3, but there was an option for 4 with like a longer token coming up.
Nice. Yeah, that totally makes sense. And right here, I think we're on, the Pokemon API is on V2. Yeah, with GraphQL, you don't really need that, but for RESTful APIs, it's important. All right, so let's create our controller. So we need our API folder. And our controller. Controller. All right, we called it an index there, so let's call it an index here. And let's see if we can get this far. Cool, so now it's asking for a view, and with like MVC, usually our view is like a literal page, kind of like how it was here. But with exposing an endpoint, our view is like, you can kind of think of it like how we're exposing our JSON data to the front end, as opposed to like, we're not the end user this time. Like we're not, with viewing party, we're not like rendering a page, we're just going to render JSON for them. How am I doing, Mike? Am I missing anything?
I don't think so. I did a tutorial on building API endpoints in the break, and it looks pretty similar. I think what I've got here is like the render JSON on line 3, equivalent to you. Like
yeah.
Oh yeah, yeah.
For sure. Let's do that. So let's grab our Pokemon so we can reuse a lot of the same functionality we already have. So we have a facade that calls our API through the service and then turns it into an object and then turns it into a database object. So we can do that here. So we can just sort of sorry, not there. We want this line. Or yeah, let's try it here first, actually. See what we have. Okay, we have a name. So yeah, let's do it. We called it our Pokey facade. And the method was the Pokemon. But yeah, if you know, if this was Rails engine and we wouldn't need a facade because we weren't calling an API, we would just, instead of like having the facade logic call our service and go through those steps, we would just do it more like a Mod2 style project. We would just say like, go to our database and get that object. You know, it would just be like a find or like a dot all for index or a dot find or find by for a show page. Yeah, really similar to Mod2. And that's where we're gonna get our Pokemon, and then we like said, we want to render it as JSON. So should we do a serializer? Let's do it. Yeah, add that down. Here, your bundle. And okay, so the command here is that we have a very similar Rails command to how we create models. So Rails generate serializer. We would call it like this, right, Mike? We would just name it there and then give it the attributes. Does that sound right? Sorry, I'm putting you on the spot.
I don't know.
Okay, let's try it. I'm pretty sure that, yeah, you're good. I'm pretty sure it's really similar to the model. So we just give it the same attributes and name it. Let's see if that works. Could not find generator. Maybe it's Rails G serializer and then you name it. No, I'm sure I couldn't find it. Okay. Let's try it with a lowercase s. See how that looks. Okay, yeah, this is what we want. So there's the command Rails G serializer, and then you give it the name, and then you give it the attributes, which are pretty much either with what's going to be from your Poro or from your table. And then this is gonna, so I don't know if you'll have the class on this one yet, but this gem was made by Netflix, I believe, and it's just a way to sort of like skip hand rolling a serializer, which otherwise you would just like create a hash in here and you would like pass in your Pokemon object, and then you would turn each thing into a key value pair and pass in how you wanted to. But this is just a shortcut, and you know, definitely my preferred way of doing it with the fast JSON gem. Yeah, let's go back to our test and see where we're at. Oops. Yeah, that's going to cause some issues. We're going to pass it. Pokemon. Oh, it has data then attributes. Key data. Why isn't it like that one? Let's go pry. Let's see what we have. Oh, because I didn't do symbolize names, I just did symbolize. Okay, there we go. Yeah, this looks more like what we expected. We expected it to have, oh, okay, so it has an ID, a type, attributes, and then they're inside of that. So let's go back and update our test accordingly. So like you can see, this is kind of what we're expecting, and we were a little off. Let me run the test one more time first, though. I think it should fail here. If anyone is lost or following along and it's not working, definitely let me know. Happy name. Yep. So we got this far this time. And I will say I did not do great on Rails engine. I was pretty lost in all of this stuff. So hopefully this is helpful so you don't end up in the same boat I was in. Yeah, attributes. So this is and let's actually go down and push these down a couple lines. And get a new variable. So we'll call this Pokemon attributes, and we can say this is our Pokemon. We're going inside of our data key, and then inside of our attributes key. So that should be inside of this hash right here at this point. Oops. And then we'll just change this. That variable. Okay. Cool. So now we have a passing test. We can call it here. So so like I said, how our view, when we're exposing endpoints as opposed to like actually giving our users a view, the way to look at it instead of like in localhost is going to be here in Postman. So what we can do is we can go to what's that one? API v1, and we called it Pokemon, and then we passed it in as name. And we passed in Mu as the name. So let's see if that works. Okay, cool. So that's exactly what we wanted. So I hope that kind of helps to visualize what we just made. So we're calling this external API where going through the facade, we're calling that API. Yeah, so this is, sorry, let me go back. So this is when the front end's calling us. So when the front end's calling us, they're going to pass in a name. They're giving us mu. And we go to this controller, we go to that route, we follow that. And then this calls our facade. Our facade calls the external Pokemon API, turns it into a Poro. And then we get that back as this object right here. And then we go ahead and serialize it, go through those steps, and we turn it into this, which is what we end up giving our front end. So this is what we created. So this is the endpoint we're exposing, and this is the one we consumed. But yeah, for Rails engine, all you're doing is exposing. So yeah, who has questions? I feel like I might have thrown you all for a loop by saving it to the database. I'm kind of second guessing whether I should have done that. But this is basically what it's going to look like this test right here. Every time you expose an endpoint, you're going to make a test pretty similar to this. Like Andrew said, you can test for the data type, or you can test for what it's going to be specifically. Yeah,
not specific to what you've done, but when we do in this project, we have to do like business logic, like get certain points in our database to serve up. Where would we do that? We would do that in our serializer, right? But how would we do that with the JSON gem? Do you know?
I'm sorry. So like you're saying like you're gonna have to create endpoints from like sort of like active record,
like
database queries.
Yeah, exactly. Like the top selling merchant in this time period. I don't know. I'm just making one up. But like, would we make like a model method for that, and then put that output as an attribute on the serializer?
Yeah, that's exactly what I think I would do. I think I would like let's say you're talking about merchants right here. I would say like, and like it's like an average of merchant sales or something. I would say like, some variable average AVG merch or something equals, and then I would call the merchant table, and then I would make a model method that's like average sales, and then I would pass in whatever we're getting from the params, and then that would go to the model. I'd have a model method there that would get whatever average I need of whatever sales, and then I would look at what that looks like right here when I get it back in this variable, and then I would create a serializer that's specific to that data that you're getting back. Or if it's just like one thing, then I would just make like a merchant average, serializer, and just pass that in and just convert it to JSON the same way. Does that kind of make sense?
Yeah, definitely. I wasn't sure like if you, okay, so when you said you had to make like another serializer, that makes sense. Like, because you want to present,
yeah,
but that's only if the data is presented differently, right? If it has the
exactly.
same structure, you can, okay, cool.
Yeah, exactly. The only time you can reuse a serializer is if you're passing in the same attributes. So if we have like a merchant show page where we're just taking like one merchant, we could have a simple show method where it's like merchant equals capital merchant dot find by ID or find by name or whatever we're searching for. And then we could have a merchant serializer where we take that merchant and turn it into JSON. And then if we have another method that's like find top merchant or something, and it uses like active record to find a merchant, but it's still finding a merchant object that has the same attributes, we could reuse that serializer and just pass them in the same way. Does that make sense?
Yeah, it does. Thank you.
Okay, cool. Yeah, that's a good question.
Well, I've got you.
For this example, if we,
what
was that?
I was gonna say.
Oh, I was gonna say if we had like a, no, you go. You go, Mike.
I was just gonna ask, do we need to test anything else in terms of serving up a happy path API endpoint apart from the structure of the data that we're giving and the data types?
This is what my test looked like throughout Mod 3. And I passed, I'll say that. But like Andrew said, we could totally add a line that's like, so let's take a look at what that could look like. Like let's put a pry right here. I think we can do dot last on our model to get like the most recent one. Oh, I'm in my real server. monster.left. Yeah, so since our facade creates it creates it as a database entry, that's going to be the last one. So we can do somewhere around here. We could say like mu equals, because every time we run this test, it's going to recreate it. So it's always going to be the last one. And then we could add a new line here that's like, we expect it to have key name, we expect name to be a string, and then we expect name specifically to be mu.name. Since that's, that's what we have here. This is our mu, and we can call .name on that, and it'll give us mu. So we could say, expect that to equal. And I'll go ahead and add some spaces in between these and just sort of like show you everything you can test for. I don't think you need to do all three necessarily, but I just want to show you all that you could do that. Oops. I don't know what shortcut that was. Image. Here's our shiny mu. Which I don't know if anyone plays Pokemon Go, but I am close to getting my shiny mu. Let's see if that still passes. Hopefully, fingers crossed. Okay, that still passes because we're finding our last entry to the database, and then we're saying like, in this specific example, we want our hash to give back the attributes of that Pokemon that we just found based on our test where we passed in mu. Does that part make sense to everyone, or am I just losing more people? Maybe a little bit. Yeah, what other questions do y'all have? If I went too fast over any steps, feel free to go back to that. Really just here as a resource. Let's say we had like another attribute or something that we set to nil, like whether that Pokemon was caught or something, and we want an endpoint that's going to update it. We could change that. We can make a new test really similar to this one, and then we could say like, instead of a get, it's going to be a patch, and then we can call that certain endpoint, pass in the params of like what Pokemon we want, and then we want the new attribute to be. We can pass that in, and then we could take those attributes, make a controller action for like an update. Expect what we want it to look like. Like we could say we would expect it to have the same attributes, and then also like the new attribute we're adding, and then we could, have instead of a create method here, we could have an update, and it could go through and update that Pokemon and then give its information back. So that's how, that's how similar all of these actions are. Just instead of get, it's gonna be patch put or patch post or delete.
So like for a delete, we'll just get the params from the request, and there would be like the ID or whatever attribute we're searching our database from. We'd search it up and then we'd delete it, and then we'll just serve back like a customized response of like, or I suppose with a delete, you would get nothing back because it's deleted. But for like an update, you would like update it and then give like the object that's been updated back, right?
Yeah, exactly. Like with the delete, you could probably put in a message that says like this has been deleted and just expect it to have that message or something along those lines. And then with an update, you could give back all the attributes, including the new one that you just updated. Yeah, again, I hope I didn't throw people off with the whole saving it to the database. I just thought it might be more relevant to know that it's coming from a database when we're going through the steps, but now I don't know if it really was, since we're still kind of calling the API here. But just imagine it's just a database object. A database full of Pokemon. Ryan, what's up, man?
Yeah, this might be a silly question, but we don't call render normally with these controller actions because we're displaying to a view, so it knows to go to the view. But when you say render JSON, is the controller just know to send out JSON to what? Like, where does it go?
Yeah, that's a good question. I think you can actually, like, with actual like a Rails 2 or a Mod 2 style like Rails app, I think you can do like a render instead of JSON, it's like render view, or you can do like the instance variables that we usually do. So I think that's just like a Rails specific command. But right now, like when we say render JSON, it's calling, we're giving it a route right here. So what our front end is going to do is give that same route, which is what we did in Postman. It's saying like, whether this is hosted on Heroku, then we would just replace our URL. And then we have the URI, that's like the actual call. And then after that, we're giving it our query params. So after this question is always going to be your params. And we're giving it a name, which is mu. So it's going to go to our routes and look for that same routes. That's going to be this one, API v1 Pokemon. It's going to take our input, whatever we gave it, and then we could we could add some sad pass that says like, if this is not a Pokemon or this is not a valid Pokemon number or something, then we're not going to give that back. We're going to give an error. And then if we do get a correct like Pokemon name or number, then this is just like returning it to them. So right now, we're calling it in Postman, but if it was a front end, like in React or something, then it would just give it back to them. So when it renders it, it's just sort of like sending out that JSON back as a response to who requested it, which is what we did right here. Does that kind of make sense? Hopefully a little bit.
Yeah, it does. And I'm guessing that React framework receives the JSON, and then essentially they just have this workspace with views. I'm guessing that they can take that information and populate the views on their side.
Yeah, exactly. Because they're going to get it as a hash, which is whatever in JSON an object is called in JavaScript, and they can just use that directly into their views. So yeah, once the front end gets it, they know what to do with it, which is kind of cool in like the Mod 4 projects. Like we don't really have to tell them how to consume our APIs, and we just like give them the JSON and then they just run with it. So yeah, so I mean, this is our local host right now in Postman, but it's, yeah, and then when we worked on our Mod 4 project, we used Postman to test it ourselves, but then our front end just called these endpoints and saved them in the ways they needed to and took that data. Any other, did that help, Brian? I hope so.
Yeah, this was great. I really enjoyed it, especially watching you make the test.
Yeah, I'm glad a couple of things went wrong, so I got to show you all a little bit of tests, like debugging. Do you have a question, Andrew?
Yeah, I'm still a little confused about the use cases of this. It seems like we took an API and then we did some stuff so that people could access the same API that we're just accessing. So why don't they just access the API the way we are, rather than having us have like 2 layers of access to get to the API?
Yeah, that's totally fair. So here it's like a really simple example. We're just taking a Pokemon and making it even more simple and then exposing it. So like, why wouldn't they just call the Pokemon API directly, which is what they would do, since I'm not going to host this anywhere. But for like my company I work at Ibotta, we like take in sales data from like Macy's when someone uses our app, and then we take what we need from their API, we convert it to how we need it, and then other services in our company will we'll convert it in the way we need it to, and then they'll take those events from us. So we have what's called event-driven architecture. So instead of like a front end calling the back end to get information when someone makes a purchase and like scans it in our app, then we just send out an event, which is basically like a JSON data like this. And then that goes to like different teams, and those teams will consume what they need, convert it the way they need to, and then expose it. So like here we could like take like a Pokemon API, but then we could also take like a Giphy API, and then we could like take the name and also you know, consume two different things. We could like consume this API to get the Pokemon's details, but then we can go to Giphy and then get like a GIF of the Pokemon we want, and then or a GIF, and then consume or expose those together to the front end. So the front end gets what they need, or we can, you know, we could take like their type and like go to unsplash.com and like their API and say like, oh, their type is fire. Let's get a picture of fire and expose that to our front end. You know what I mean? Like we can like take the data we need, or we could get more things, or we could add to it, or we could subtract from it like we did here, and then expose it the way we want to. So that's kind of the purpose here. You know, it's kind of hard to see, like you said, like with a super simple version, like why would they need to do that when they can get like the full information themselves? But there's a lot of practical uses for different companies. But yeah, that's a really good question. Another example, I made an app for a client before I started my job at Ibotta, and Mike actually like took a look at it and helped me out a little bit. But it was for my friend's small business, and he has a bunch of delivery drivers who deliver things here in Denver, and they use a software called Optimal Route. So what I did was I consumed their Optimal Route API endpoint and got all their route details with all the stops the drivers make daily. And then I turned those into a route table and a stop table, saved it all to the database. And then their front end can consume it from me, but you know, they don't need what they get from the API directly. They need what they get from the back end, because we're taking what we need out of it, creating those relationships, and then just exposing what the front end can actually use. If that makes sense. You know, it's a super high level description since there's a lot to it, but I definitely recommend looking into like service-oriented architecture, microservice architecture, event-driven architecture, and just see like the different ways companies use these things. So you have more of like a high level, like broad picture of like what you're actually doing, so that it doesn't just feel like you're just like taking data from one place and then turning it into something else and exposing it. So you can actually see like what the goal is here for actual like companies that are gonna want these skills. I don't know if that was too much detail, but I hope that's helpful. Cool. Any other questions? Oh, sorry. What were you gonna say, Andrew? Cool, y'all. Well, I hope that was helpful. If there's anything confusing, feel free to send me a Slack message. I know it's a lot of information at once, so don't feel like you have to know this all immediately. Like you'll definitely get some practice with Rails Engine and then Sweater Weather and the consultancy project. So just try to like take away what you can from the group projects and try to get your knowledge of, you know, just basic consuming and exposing down in this mod. And you know, as long as you get that out of it, I think you're good to go and you're in a good spot for the job hunt.
Thanks, Sage. Thanks for your time, man. Like, definitely.
For sure. Yeah, no problem. Thanks for stopping by, everyone. Really appreciate it.
Thank you.
Have a good
Yeah, thank you.
weekend.
Yeah, no problem.
Thank you.
You too.